In this video, I'm going to introduce the concept of curves defined by parametric equations. So let's consider this curve here. And I want you to notice that I'm not calling it a function. So let's say we have something that looks like this. Starting from somewhere in negative infinity. But when we're talking about parametric curves, these curves traditionally have a direction. So let's say that this curve is going in this direction. And then it will continue. So you have a curve. I'm going to call this curve C. And then the points that defined the curve, so let's say that point there is considered a point as an order pair. Let me call it x, y. But your x and y, or your order pair, let me put it here, is in terms of a third variable. So x, we're going to say that it is f of t. And y, we're going to call it g of t. Or we can also say it is x of t and y of t. So we can think about x as x of t and the y component as y of t. And if you think about them in that form, x and y, or x of t and y of t, are called parametric equations. So if f of t and g of t, the way I have it here, are x of t and y of t, and they are called parametric equations, then the t here, I'll just put and t is called a parameter. Okay, so vocabulary, parametric equations, parameter. We have this curve C. Because it is defined by parametric equations, we can call it a parametric curve. Okay, so we have a parametric curve. If we have a parametric curve that starts at some point and ends at another, because notice here I said it's going to start from negative infinity and it's going to continue with this arrow here. If I think about a different parametric curve, so remember this is x, this is y, but now I'm going to start here. So I'm going to call this an initial point. And then it's going to go in this direction. It doesn't always have to go in that direction. It can go anywhere. But let's say it stops right here. So if this is called the initial point, then this point is called the terminal point. Okay. So we have, again, points in the form of x of t and y of t, where x is equal to x in terms of t and y is equal to y in terms of t, and we call those parametric equations, and t is called that parameter. Okay, so we can think about a different curve, and I'm going to just say that this here is my initial point. So I just want to change it. And then let's say is something like this. And this right here is the terminal point. And then remember, if I started at the initial point and went towards the terminal point, then the direction that we took was something like this. So now it is going in this direction. So we can say that as t varies, and this is in general, regardless of direction. So as t varies, the order pairs x, y, which remember are in the form of f of t and g of t, or x of t and y of t, varies. And it obviously is tracing this parametric curve. And therefore traces the parametric curve. And I'll just call it C. In many applications, T represents time, but it really doesn't have to. It can represent other things, and for other things, we traditionally use other variables or variables that are not T. Okay? But we can think of T as a parameter, and in most applications, this third parameter represents time. Let me look at an example here. I want you to notice that this parametric curve doesn't necessarily pass the vertical line test, so it's not necessarily a function, which is why we're calling it a parametric curve. All right, so let's look at x equal to t cubed plus t, and we want to let y be equal to t squared plus 2. So you can see here that x is really a function in terms of t. So x of t is equal to t cubed plus t. Or using this notation, we can say f of t is equal to t cubed plus t. And then y, again, we can call it y of t, which is g of t, and g of t is equal to t squared plus 2. So you can think about y squared being a function, g in terms of t, where t squared plus 2 represents a function. But again, the curve that this parametric equations are tracing is not necessarily a function, okay? Doesn't have to be. So what we want to do when you sketch the graph, let's say sketch the curve C defined by the parametric equations. So defined by, and then again, x equal to t cubed plus t, and y equal to t squared plus 2. So what you want to do when you want to sketch is obviously you're going to look at sketching in the rectangular coordinate system. Where, we have x and we have y. And then what you want to do too is kind of like create that t table that we used to create in algebra. So we're going to have a parameter t, and then we're going to have x and y. So we can let t be the independent variable, if you think about it as a variable. So we can let it be anything we want. We can let it be 0, 1, 2, 3, or -1, -2, -3, and so forth. Let's start at 0, and let's look at just the x values. So when t is 0, x is 0. When t is 1, x is 2. When t is 2, we have 8 plus 2, which is 10. And then we have 27 plus 3, which is 30. When t is equal to -1, we'll have negative 2. When t is equal to negative 2, we have negative 8, so this would be negative 10, and negative 30. You need to wait to find out what the y components are, because remember, when you're graphing these points, they are graphed in terms of x and y. You can see it over here. You can graph them in terms of x and y, and then you have a direction. Okay. So let's get the y components and see where that takes us. So looking at y now, when t is 0, we're here. When t is 0, y is 2. When t is 1, we are at 3. When t is 2, we are at 6. When t is 3, we are at 9 plus 2 is 11. Negative 1, we are at 3. At negative 2, so that's 4 plus 2 is 6. And then we have 9 plus 2, which is 11. And then what you want to do is you want to plot the points or the order pairs x comma y. So we have negative 30 comma 11. Negative 10 comma 6. Negative 2, 3, 0, 2, and so forth. I'm going to start with, just because I don't want to spend time in the video, I'll just do a sketch of the points. So we'll do an approximation. So let's start with 0. We are going to be at 0, 2. So somewhere over here. This point happens when t is equal to 0. And then we're going to have 2, 3. So x is 2, y is 3. We'll put it somewhere over here. So that happens at t equal to 1. We're going to be at 10, 6. So we'll put it over here. So t is equal to 2. And then we have 30 and 11, so we'll put it somewhere over here. Okay, this is just an approximation. X is 30, y is 11, but that happens at t equal to 3. When t is equal to negative 1, so now we're up here, when t, and then I want you to notice that the direction that we're taking is this one here. So you're going to have something that looks like this. And of course, if we stop at 3, then that would be considered a terminal point if we stop at 3. But if you don't stop, if it continues, then the idea is that it's going to go somewhere in this direction, right? Either here, here, or here. You would have to continue plugging in points to find out where is it that this curve will continue to go to or towards. When t is equal to negative 1, we are at negative 2 and 3. So that would be somewhere over here. And then we have when t is equal to negative 2, we are at negative 10, 6. And then when t is equal to negative 3, we are at negative 30 and 11, so somewhere over here. But the direction is like this. This curve C is the parametric curve defined by the parametric equations. If we restrict t to be between negative 3 and 3, then it would stop right here, and that would be the terminal point. And then it would start somewhere over here, and that would be the initial point. All right, I'm gonna stop here for this video.